Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into our 9th grade topic, solving a system of linear equations using the elimination method. Now, I've already made a video using the substitution method, so if you hadn't seen that video yet, I'll put a link to it right up here. If you're new to my channel, I'll be putting time codes in for this video in the description box below, so feel free to check that out and skip ahead to whatever part of the video interests you the most. If you have any question about what you see here today, or even your own homework, remember you can put them in the comment box below or visit me on Facebook at Tutor Me Sempai and tell me all about it there. When you find this video helpful, remember to leave a like. It really helps the channel and I can't express how much I appreciate it. Also, remember to hit the notification bell, smash the subscribe button, and share this video with a friend. Well, without further ado, let's talk a little bit more about this elimination method. Before we start tackling our system of equation with the elimination method, we have to discuss how to do the elimination method. So I have 5 easy steps for you that will do just that. Our first step is going to be line up / rewrite. Now there'll be a few times where your system is not necessarily lined up properly. All the x's or the y's or the z's, whatever variable you're using, they might not necessarily match depending on how you're looking at it. So for example, if you look at this, these are not lined up correctly. Your x's are not over your x's and your y's are not over your y's. You could also have something like this. In this case as well, you see your x's and your y's are not over each other. So if you're ever given something like this, you want to first, before you do anything else, line up and rewrite it so that you have your x's over your x's, your y's over your y's, and any other variables you have them all over each other. Our second step is going to be pick a variable to eliminate. Now this step is really just a personal preference. There'll be some times where it's very easy to determine which one you want to eliminate, and there'll be some times where it's not so easy. However, you have to pick somewhere to start. So whether you want your x's gone, or your y's gone, or your m's gone, or your n's gone, or any other variables, just pick a variable that you want to eliminate, and then we can move on to our third step. Step number 3, multiply our canceling constant across the entire equation, both left side and right. You want to multiply the entire thing by what I call our canceling constant. Now, what is a canceling constant? So let's say you had x plus y equals 5, and you have 2x minus 3y equals, let's say, 10. Our canceling constant is going to be the constant that when multiplied by whatever equation, the whole thing cancels out the variable that we chose. So let's say we want to eliminate this x. We can multiply this top by a -2, right? The entire top, because when we multiply this and then combine for our next step, this x is going to cancel out. So this -2 will be the canceling constant. Multiply the entire top. So by the x, by the y, and by the 5. You want to multiply the entire top by this -2. Step number 4, combine. After you multiply the entire equation by your canceling constant, you can just combine everything, add, subtract, whatever the signs are, combine everything, and your variable that you chose to eliminate should naturally fall off, leaving whatever is left. Now, this was a system of 2 variables in which you had 2 equations. After you hit the combine step, you should just be left with 1 variable and exactly what it equals. If you have more variables and more equations, you have to do a little bit more repetition here, but this is just going to be the simple steps if you have a system of 2 variables, which means you have 2 equations. After successfully eliminating 1 variable, you should just have the remaining variable left over, and you should know exactly what it is. So once you know exactly what it is, our 5th step, which I want to put right next to because I ran out of space, is just going to be plug in that variable. Once you plug it in, you should be able to solve for that other variable, and now you have both the variables that you were solving for. So it's really just plug in and solve. We've talked about how to do the elimination method, but why should you do the elimination method? If you already know how to do the substitution method, why do you even need the elimination method? Now I have a few pros and cons to share with you, but this is not an exhaustive list. This is just some things that kind of bubble up to the surface that you may find out once you kind of jump in and get used to using the elimination method. Ultimately though, this is going to be up to you as a personal preference whether you do elimination or substitution. So the first pro I have for you is, it tends to be a little bit faster than the substitution method. So if you're really crunching for time, and especially if you only have like 2 variables, something really small, the elimination method tends to be a little bit faster than the substitution method. So to counteract this pro, a con that I've run into is the elimination method is not as intuitive as the substitution method. So it can be a little bit more difficult to grasp at first. So if you think about the substitution method, all you're really doing is isolating a variable. You have a lot of practice doing that up until this point, so doing it repetitively is not going to be adding much more to the difficulty of the question. However, the elimination method is having you doing something a little bit different. That can be a major stumbling block for somebody who is very easily confused. So, as far as simplicity's sake, solving the system using substitution is just something you're more naturally used to since you're used to isolating variables. Another pro that I have for the elimination method is you can focus on one variable. Now what do I mean by that? Well, there might be some times where the question will ask you, what is x, or solve for y, or whatever other variable. Well, if you can eliminate one variable, leaving the variable that you want, yes, it's faster, but it's faster because you can focus on the one variable and not have to solve for both variables. So it kind of builds on how fast it can be because you can focus on the variable that you want at that time. You don't have to solve the entire system, whereas substitution, in order to get what you want, unless they already isolate something or something just kind of falls off naturally, you're gonna have to solve the entire thing in order to get what your variable is. So the substitution method doesn't allow you to really focus in on one variable since you're gonna have to isolate and then plug in and then solve that, and then hopefully you can get what you want from that. Whereas the elimination method allows you to eliminate one variable, leaving the one that you're interested in. So another con I have for the elimination method kind of branches off from its complicated nature. So when you compare it to the substitution method, you have a few more steps. But when you add more variables, thus more equations, you actually increase how many steps you have as well, opposed to the substitution method, which is just going to be a rinse and repeat kind of method. The substitution method just has you isolating, plug in, isolating, plug in, isolating, plug in. So no matter how many equations or variables you have, you're going to be pretty much doing the same thing until everything is done. Whereas the elimination method has you with a few extra steps to kind of make new equations as you are going through your variables. So the con is you add more steps when you get more variables. So the last pro I have for you actually may stem a little bit more from personal experience. However, I thought it would be good to kind of put on the table and you can kind of check this for yourself. But for me at least, a pro that I've seen is that the math involved in doing the elimination method tends to be a little bit easier than the math involved with the substitution method. Now, what do I mean by that? I can't have it both easy and more complicated, right? Well, the math is easier. Yes, you have more steps, but you're less likely to get confused with the math portion of it, I believe, with the elimination method. So how is the math easier? Well, look at the substitution method. When you do the substitution method, you're isolating a variable, and then whatever that variable is, no matter how ugly it is, you have to plug in that variable into another equation everywhere that variable exists. That can get really ugly really fast, especially when you're dealing with fractions and you have this huge equation that you formed when you isolated one variable, and you have to keep up with all that, hoping that you don't miss a sign or something else. It's very easy to make a mistake with the math with that, whereas you don't really have that problem with the elimination method. The only time you're gonna have to worry about plugging in something with the elimination method is when you're solving at the very end for your variable values. And the only thing you're plugging in at that point in time are just more constants. Whereas for the substitution method, you're actually plugging in expressions, and those expressions can be very big and ugly. We talked about how and we talked about why, but now let's jump into our question of the day and see it play out before our eyes. Here we have a system of 2 variables, 2 equations, in which the first one is y equals 3 minus x, and our second one is 3y plus x equals 5. So we're going to go through our steps. I rewrote them here in shorthand, and we're going to go through each one and solve the system. So the first step says line up and rewrite. You may notice that this is not how we want it. y's are over each other, but the x's are not. And you see the equal is all the way over here. So we want to rewrite this in such a way where everything is over itself. So the y's, the x's, and the constants, we want everything to be over itself. So you see, line up, rewrite. Now I gotta pick a variable to eliminate. This is a personal preference. You can pick x or y, but you have to pick one of them. I'm gonna pick x because to me, x is gonna be a lot easier to eliminate. So x is gonna be the one I eliminate. Now I have to find my canceling constant. What can I multiply by in order to make x go away? Well, we see these x's are both positive, and it's an understood one in front. So what do I need in order to have these go away? Well, if this is a 1x and that's a 1x, I need to subtract them, right? So our canceling constant needs to make one of these x's negative. Well, how do I do that? Well, I multiply this by a -1, right? So I'm going to multiply the top by -1. The entire top. Multiply across the entire equation. So this side and this side of the equation is going to get multiplied by a -1. And I'm going to rewrite this so it's going to look like -y minus x equals a -3. So you see, I rewrote the top multiplying -1 by the entire equation. And then I'm going to simply rewrite the second equation here. So 3y plus x equals 5. Notice I'm keeping everything on top of each other. All the y's, all the x's, and all the constants. And your equals are all over itself. Now I can combine. Notice our x's are going to go away. And when you combine this, it's going to be a -y plus, we're going to add everything. -y plus this 3y, what do we get? That's going to be a 2y. X's go away. -3 plus this 5 is going to be 2. So what does y equal in this case? Well, if 2y equals 2, y has to be 1. So we found what our y is. So we've combined everything. Now we have to plug in the y and solve for our last variable, which is x. So if we plug in y, let's just plug it into the first one. 1 equals 3 minus x. What does our x have to be in order for this to be true? So we have an x equals 3 minus 1. Now what is x? Well, x is going to be 2. So now we solve for both x and y, and we know the answer for this system is going to be x equals 2, y equals 1. But our sixth step, really, because this should be part of your step, especially if you have time, is to check your work. So I'm going to just add a makeshift sixth step here. Check your work when you have some time. You know, it's a really good habit to have. So let's check our work to make sure that this answer is really correct. So plugging in, 1 equals 3 minus 2. Is that correct? Yes. Next we have 3 times 1 plus 2 equals 5. That's 3 plus 2 equals 5. Is that correct? Yes. So now that we see that when we plug in our x's and y's into both of these, make sure you plug them into both, not just one. If you're checking your work, it has to satisfy both equations. If you plug it into both, you see they both work. That means all 6 steps have been followed and we have solved our system. X is 2, y is 1. So I hope you're able to follow into this example, and I hope you understood some of the pros and cons when you're comparing the elimination method versus the substitution method. If you have any questions about what you saw here today, or even your own homework, remember you can put them in the comment box below, but if that's not enough space for you, visit me on Facebook on my page at Tutor Me Sempai. If you haven't done so already, remember to leave a like. It really helps the channel, and I can't express once again how much I appreciate it. Before you go, don't forget to hit the notification bell and smash the subscribe button, as well as share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.